So students, now here we will talk about the rate of diffusion. The rate of diffusion, which was described by the Adolf Fick, who says that rate of diffusion is directly proportional to the concentration gradient. He says the rate of diffusion is directly proportional to the concentration gradient, that is represented by means of delta Cs upon the delta X. So this is particular concentration gradient. So delta Cs upon the delta X, which is represented as, and delta Cs is the basically the difference in the concentration gradient of a substance. So it is the difference in concentration gradient of substance. That means difference in the sense the initial value and the final value. Initial, in which the rate of concentration at one place is the higher, and when it has to move towards the final stage where its concentration is low, so that particular difference in the concentration gradient of the substance is represented as the delta Cs, and that particular distance, this particular distance is known as the delta X. Okay? So that is the 2 points separated by a distance, that is the delta X. So here the rate of diffusion that becomes directly proportional towards the delta Cs upon the delta X. So according to which the Fick's first law states that Js Js is basically the flux density. So flux density is the amount of substance crossing a unit area per unit time, and that means the substance which is going to be diffused on. How much amount of a substance is crossing that particular unit area, or the distance that has to be covered by that particular substance per unit time. So that is known as the flux density, or it is represented as the Js. So which is equals to the minus ds. Ds is the basically the diffusion coefficient. So it is proportionality constant that measures how easily substance moves through a particular medium. So minus ds, so delta Cs upon the delta X. So here minus sign indicates that the flux moves from down a concentration gradient. So that means the substance has to move from the higher concentration towards its lower concentration. So we can calculate the flux density or the rate of diffusion, so which is equal to the minus ds, that is the diffusion coefficient delta Cs upon the delta X. So this is a particular equation which is from where we can calculate the rate of diffusion. So next is the independent diffusion. So first we have talked about the diffusion, simple diffusion process. So next is the independent diffusion. Independent diffusion means like if one or more substances two or more substances are moving or diffusing at the same time. ठीक है, at the same time अगर diffuse on करते हैं in a particular system, so that basic process is known as independent to each other, without affecting the movement of each other. So that basic process is known as the independent diffusion. So independent diffusion, we can simply say that a diffusion system which contains two or more substances. So दो या दो तो वक्त जो substances ने at a time that they diffuse on करते हैं without affecting each other's movement. So that particular process is known as the independent diffusion. So the examples, like the general examples of the carbon dioxide, oxygen and the water vapors, when are moving in the are involved in the diffusion through the stomata, during the stomatal opening and their closing. So they are moving from that particular stomata, so carbon dioxide, oxygen and plus water vapors. So diffusion pressure of an individual is equal to the partial pressure. So the different substances diffuse independently according to their own concentration gradient or the partial pressure, like in this particular diagram. So which shows that the moment of the water vapor, here the water vapor, oxygen, water vapor, oxygen and plus carbon dioxide, like during the time of gaseous exchange during the time of photosynthesis or the respiration. So where the requirement of the carbon dioxide towards the inner side of the cells. So outer side of the stomata, the concentration of the carbon dioxide is higher than that of the inner side. So that's why carbon dioxide moves towards the inner side of the cell, whereas oxygen, where concentration of the oxygen is higher in the inside of the cells and lower towards the outer side, so that why it get diffused out of the cell. And similarly the water vapors also, so which also get moves out of the cell. So these three basic substances or the three basic molecules are moving independent to each other without affecting their own rate. So that basic process is known as the independent diffusion in case of the gaseous exchange in case of stomata. So next is the factors affecting the diffusion, rate of diffusion. So first factor है अपने को